co-workers and collaborators over the last year. So to kick things off, let's talk about the writing process to lay down a framework of what people do when they write. So there has been extensive research done on the theory of writing dating as far back as the 80s. It describes writing process as a complex and effortful cognitive task where writers balance and orchestrate three different cognitive processes: planning, translation, and revision. However, contrary to the theory, the writing process is not linear, it's recursive. It leaps forward and jumps behind. You might want to work on a particular different stage, but you might want to go back in the process and revisit a different stage to improve your line of thought, find something that you had not thought of before, and so on. So while it is a strategic and adaptive process, it's more importantly an iterative process. And human writers are unable to simultaneously comprehend the different demands of all these different stages. And as a result, they turn towards making successive iterations to reduce the number of considerations at each time. And this phenomenon of iterative revision is the topic of my research, which I'll share with you today. So, however, with large language models, everything has changed. Similar to the differences that we see in the writing process, the process of writing assistance has also undergone a major shift. So broadly speaking, conventionally, writing assistance has been generally system-driven, push-based protocol, where a user would type their text, the system would evaluate it against some machine learning models, provide a set of suggestions, which the user could accept or reject, and this would go on for a few turns until the system didn't detect anything worth improving. But now, more recently, because of large language models, it's more of a conversation with an LLM that's powering the system, which provides a much more collaborative revision experience. And here you can see that it's the interaction with the writing assistant starts even before a single word in the document exists. The user can write the first draft like they did before, or now they can provide instructions about what needs to be written, and the system will generate the first draft. The evaluation will proceed in the same way, but now, at the revision stage, the user can either continue revising like they did before, or they could rely on the system to evaluate the revised document, suggest improvements. And if the user chooses the latter, the system could go ahead and make more revisions. And the interaction will just proceed like any other conversational system. So if we remove the older way of composing and revising text, we are sort of left with this. And if that is unraveled through time, you can see it's like a user having multiple interactions with their writing assistant. And this sequence of interactions spans multiple stages of the writing process that we discussed before. So with this new paradigm of writing assistants, it has a lot of challenges. And we focused our work to these three different research questions: to understand the writing process itself, to model it computationally, and to improve the user and model interactions to make it more and more efficient and effective. So iterative text revision, as I said, is the theme of our work. So let's dive in. We organize our investigation of those three research questions into these four different steps. We first built a taxonomy of the users, of the process of iterative revision. We used this taxonomy to build a data set collected from at a very large scale using crowd annotators. We used that to build better computational models of the iterative revision process, and use these models to build a human-in-the-loop text revision system to make it more interpretable and efficient. So as part of our focus on the first research question, we started exploring the writing process itself. In the interest of time, I'll keep this one short and refer you to our paper from ACL 2022, where we proposed a taxonomy and built a data set. So as you can see, this taxonomy of text editing is focused on non-meaning changing edits, and it's generally applicable to multiple domains, different edit action granularities, and different revision depths. So we collected a large set of raw documents from a variety of public sources where we see that people write documents across different revisions. So there is iterative revision going on. And for each document, we sort them by their timestamps. We get different versions. And what we did was got them annotated at scale using crowd workers according to the taxonomy that we proposed earlier. So this gives us a foundation in the form of a real-world data set to understand the cognitive process of iterative text revision, which we can build models on and try to figure out how to make this process of writing assistance even better. So in the next section, I'll cover different modeling approaches we explored and model the process using the taxonomy we proposed and the data set we collected. And this will simultaneously answer the next two questions of how can we provide better suggestions in a writing assistant, and can we make the process of writing assistance more effective and efficient. So when it comes to modeling the writing process, over time, we have seen three distinct patterns which forms the body of our work. These are called system-driven, user-driven, and mixed initiative writing assistant systems. And they differ along these three axes. Interaction is defined as who drives the revision interactions. Revision is defined as who out of human and machine performs the revisions. Evaluation is defined as who out of human and machine evaluates the quality of the revised text and drives this, the next steps in the interaction. So our first work called Del Iterator, which is quite system heavy, has the system driving the entire text editing process. We followed it up with the other extreme called co-edit, which is mostly user-driven, where we leverage instruction tuning to enable the user to drive both the initiative and the evaluation. And finally, we propose a more balanced and collaborative approach called CT-RLHF, still under review, where we leverage human preferences to empower both the user and the system collaboratively to drive the revision process. And that enables a much higher quality revision experience. One thing to note here is that the machine will always be a primary driver of the revision. So more specifically, I'll first describe the system-driven model. I'll go into each of these, first starting with Del Iterator. So here's a little bit more detail about how we model the system-driven writing assistance. We propose a two-step approach here. We first perform edit intent classification, which first predicts the spans that need revision. And then for each detected span, we have another model which actually performs the revision. And once we apply this to the full document, we have a new document revision. So here we see it that given a document with n different, let's say, sentences, for the sake of simplicity, we take a context window of k sentences. We first predict the spans, make the revisions. We get to a new document version. And this process keeps going on till the system decides that no other revisions need to be made. Now I'll describe the user-driven model called co-edit, or collaborative text editing through instruction tuning. So in this work, we explored the other end of the spectrum, where we gave full control of to the user to drive the revision process. And as you can see, over many iterations, the revision interaction, the revision itself, and the evaluation is all driven by the user, where the system is sharing the main responsibility of only generating the revisions. So in co-edit, we replace the automated system-driven edit detection and revision generation with a more user-centric interaction, where the user can provide instructions in natural language, and the revision model, which is an instruction-tuned large language model, can perform the edits. Note that the user can also make the revisions here, which is why it's predominantly the user-driven experience. And one can argue that, yes, this is the other extreme, from being completely system-driven in Del Iterator to being completely user-driven here. Finally, we came up with CTRLHF, which tries to address the limitations of both the previous systems pertaining to the 3 steps, all the 3 aspects of interaction, revision, and evaluation. And as you can see, every stage has both human and machine responsible for driving it. Either the human can come up with how to evaluate or what to revise, but the machine can also make suggestions for doing the same things. So it's a very much better collaborative process compared to either of the 2 prior systems. So if we look at a more simplified version of CTRLHF in the context of the older architecture diagram I was sharing, given a document in the revision cycle, we replace the predominantly user-driven interaction with a more collaborative system. And we do this by primarily leveraging RLHF, learning from human preferences, and also using LLM ensembles. So we leverage an ensemble of 4 different large language models to first understand the quality of a given piece of text editing along different evaluation criteria. And the output of this ensemble is used to provide the reward to train the text revision model so that it can make better revisions. And in this way, we are able to introduce collaboration in all aspects of the system. So in the next section, I'll present some results pertaining to both the modeling and human-machine collaboration. So across our modeling and human-machine collaborative writing explorations, we observed that while instruction tuning has been incredibly powerful of a technique to improve the quality of revisions, RLHF training is able to improve it further, and especially along the more subjective criteria of style and coherence. In contrast, we also conducted experiments against ChatGPT. It was a year ago, so yeah, these results might be outdated a little bit, but the general principles are the same. And our models were able to outperform, while ChatGPT was able to outperform our systems on style and fluency tasks, it lacks much far behind on coherence and clarity, which can be attributed to its preference to be really verbose or have more creativity in its writing, which could be good for paraphrasing, but not so good for when it comes to correctness, which have much more objective criteria compared to creative tasks. And at the same time, our models are able to do this while being much smaller than ChatGPT. So the red dots that you see at on the top right are our models, and the x-axis is on the exponential scale of model size. I'll again refer you to the paper for other results. So we also conducted qualitative human evaluations by asking qualified users to use our system for iterative revision using different models at the back end. We found that in terms of our human evaluations, the ratings were in line with automated metrics, where CTRLHF did better than Coedit, which in turn did better than Deliterator. However, ChatGPT scored quite close to CTRLHF, which was better, if you remember in the previous slide, in terms of automatic evaluations. So this indicates the limitations of automatic metrics, that there is a huge need for better document-level evaluations for text editing. Finally, we also measured the efficiency of our mixed initiative by removing the human interaction from our system and asking different qualified annotators to evaluate the revisions made by our system. And this gives us the system-only revision, where we just let the system make the revisions, and we ask the annotators to judge whether the final revised documents had improved quality. And on the contrary, we compared it with mixed initiative revision. And you see that in mixed initiative revision, the average depth has gone down, which means the writers don't need to make as many revisions to get to the desired quality of their document, which signals at efficiency. Similarly, the number of edits required has reduced, which again means that the system is able to make much better suggestions which the users are able to accept, which leads to a reduction in the number of edits made. Again, and of course, the quality has improved, which is again a great, which confirms the finding that we saw in the number of edits. But the interesting thing is that the average time to get to the final document revision has increased, which means that mixed initiative setting has led to a slower revision process. So even though the number of edits are getting reduced, the average depth of the document is getting reduced, but the writers or the users are spending a lot more time either thinking about what to evaluate, how to revise, or interpreting what the model gave them. So even though it improved quality, reduced the number of edits, it did make people a little slower as they had to evaluate the system suggestions, which was a little counterintuitive, but makes sense. So yeah, to sum up, our proposed systems demonstrate improvements in quality based on our results from the three different works that I talked about. In terms of effectiveness, we find that human-machine collaborative revision works way better than any other alternatives that skew the control of interaction, revision, or evaluation to either party, the user or the system. And in terms of efficiency, yes, while collaborative revision improves users' quality of writing, it also leads to slower revisions. Right, so more recently, we also published an extension of the co-edit work at NACL this year, where we scaled it up to 7 different languages in both multilingual and cross-lingual settings, where a person could provide an instruction in one language for a text that is in a different language. So if you see, in the multilingual settings, the edit instruction and the text that needs to be edited are in the same language. This is the multilingual setting. In the cross-lingual setting, the language of instruction and the language of the text are different. So so our models work even for cross-lingual text revision use cases. All of these are publicly available on Hugging Face and have been pretty popular and have shown strong performance on multiple text editing tasks and across many languages, even the languages where we did not fine-tune these models on. In terms of future work, we aim to improve the contextualization of our systems. We want to make them provide better suggestions for different users and different writing needs. We hope to invest some effort in formulating better evaluation frameworks to address the gaps in evaluating the task of iterative revision and accounting for document-level quality, revision history, and user preferences. And finally, we aim to improve this human-in-the-loop writing process by learning to provide the most effective suggestions. And finally, I'd like to leave you with some examples of how we are leveraging this research in the Grammarly product. And these are all GenAI features currently being offered in the Grammarly product. You could compose, you could revise, you could respond to any piece of text. We also had a version of this. We also had a version of this on mobile where we leverage speech as users' input to articulate what they want to write about, and we give them the ability to compose and edit documents, messages, and notes, all with their voice. And that makes the writing experience really convenient and easy to use on the go. And that's it. Thanks a lot, everyone.
Thank you, Vipul. Don't leave yet. Thank you for speaking to us about what you're doing at Grammarly, your work and your colleagues' work. We have Salvador on stage left. If I mess up this, don't mind me. Follow my pointing. So Salvador on the left, stage left with sorry, you're right. Salvador and Anish, they both have microphones. So if you have a question for Vipul, please raise your hand. Make contact with either of those two gentlemen. Looking at me won't help you. Get the microphone. We have time for a few questions. Okay. So we have a question on the left.
Hi, thanks so much. A quick question. You talked briefly or touched briefly on it, is how to get it to write in your own style.
Sorry, I'm not able to.
I said you talked briefly on the ability to, the Grammarly is coming out with, where you can put in your writing style so that it sounds authentically like you with your, idioms, your isms, your sayings. How do you guys view that interface happening? Because right now, for example, in ChatGPT, what I have to do is put together my writing style guide. I have to put together all these documents, writing techniques, so that when I get the output, it actually sounds like me,
right?
80, 90%.
So anyone's writing is influenced by a lot of different things, and those things or those signals can be inferred or explicitly collected. Either you as a user could provide that signal that, okay, this is the industry I work in, this is my job role, and so on. Or there's a lot of, it's been a very old problem in machine learning to learn a user's writing style. So yeah, if we were to do this in a privacy preserving manner, yes, it would ideally maybe be on device, where we continue to learn who you are as a writer, or look at your personal dictionaries that based on what you've the suggestions that you've accepted and so on. And yeah, this is just like a very basic way to do this. But yeah, there's a lot of, you can think of user modeling, like a lot of ways in which one can build a representation of a user based on what they write, who they are, and so on. But yeah, the critical thing is to do it in a way that's responsible and protects the user's privacy.
We have a question in the middle.
How do you train the model to only edit like specific area? I think you talked briefly about having a separate model for span prediction and editing.
Right.
Could you explain that more?
Yeah. So these are. So if you. I think it's I'll have to scroll a lot because it was in the earlier part of the presentation, but there were, from the data that we collected and annotated, we now in that data set we have pairs of sentences, a sentence that was maybe corrected with a certain intention. So that's exactly what we need to train a model, that given a piece of sentence, what are the spans that were edited and with what intention, and that's what the first model predicts. The second model learns to actually make those corrections, that, okay, given the span and given the edit intention, how do I generate the revision? Yeah.
Okay, so we have a question on the left, and we have time for two more. So this one and one more.
Yeah, I'm curious, which use cases do you think your research, whether now or the stuff you're looking at next, you have the most potential to impact and create an efficiency for? So,
I mean, now writing has changed, right? It's not something like, okay, that's kind of what I was, that was like the central point of my talk, that instead of, you writing and, just blindly accepting what something like Grammarly would tell you, you have the power to actually critically evaluate how you want to drive that process forward. So you can think of any piece of writing, whether you're writing a document, an email, maybe you're responding to an email, writing something on Slack based on some thread that's going on. Any piece of writing can now be driven collaboratively by the user and by the large language model. Does that answer your question? Outside of writing, well, this is focused primarily on writing, but yeah, any creative process or any process which has any requires any cognitive overload and has clear evaluation criteria, has the room for any mixed initiative modeling.
Last question on the left.
Okay. Two questions. One, can you share your slides? And two, how well does your model produce content that does not trigger in a written by AI censor?
So most of this work was focused on revision. So there is an implicit constraint in the task that we are pursuing. There is something given that the user wants to accomplish, and that really grounds the what the model is supposed to generate. But yeah, that's a whole different area of research as to how we can make the models more aligned and so on. And you can provide those additional signals in the generation process to control for that.